Hello everyone and welcome back. In today's lesson, we'll be talking about streams, floods, and introduce the hydrological cycle and its important role to streams. We will also talk about specific features of streams, including sediment transport, velocity, and gradients, as well as sediment deposition. With water playing such an important role in our everyday lives, with streams, rivers, and large body of waters also serving as a means of transportation, however, these can also cause catastrophic hazards in the form of floods. Before we talk about the hazards, we must first describe the hydrological cycle and how water is transformed. When talking about the water that is stored on, under, or above the Earth's surface, this is known as a hydrosphere. The oceans are the largest reservoir of water, accounting for 97.5% of the Earth's water. The hydrological cycle, also known as the water cycle, accounts for the movements of water primarily through evaporation, condensation, and precipitation. Water evaporates from the oceans, lakes, and other bodies of water, and also from plants in a process known as transpiration, where it is then condensed into clouds. These clouds then store the water as droplets, which can come back down as rain or snow, known as precipitation, and returns back to Earth. Water that percolates in the ground can enter aquifers and eventually re-enter the ocean. Now that we have a better idea about how water is transformed and moved, we can start talking more about streams and their features. A stream is any body of flowing water, regardless of size, from a small trickle to a large river. Streams pull water from a drainage basin or a watershed, which is any area of land that collects precipitated water. Drainage basins connect together in a hierarchical pattern, and smaller streams can feed into larger ones or lakes. These are referred to as tributaries. There are varying types of drainage patterns, with some common ones being dendritic, trellis, and radial. The most common pattern is dendritic and resembles that of tree roots. These patterns are formed where the rock can be easily eroded and typically consists of granite, volcanic rock, sedimentary rock that has not been folded. This differs from a trellis pattern, which is a result of sedimentary rock that has been folded or tilted to varying degrees, where radial drainage patterns are circular and concentric. No matter the drainage pattern, streams act as a transport for a range of different materials. Heavier material can be moved by traction, where the material is pushed or dragged along by the flow of water, where medium weight material can be moved by something known as saltation, which is when the material is bounced along the stream bed. In order for these materials to travel through the stream, the velocity of the water needs to be strong enough to actually carry them, and it also depends on the stream capacity to transport material. This is referred to as a stream's load. Another factor to consider is a stream's discharge, which is the amount of water flowing over a fixed point over a period of time, typically expressed as cubic feet per second. If a stream flows into a lake or a standing body of water, the stream's flow drops to virtually zero, dropping any sediment to the bottom. If you've ever looked at aerial photos of waterways, you might have noticed that streams do not always flow in a linear fashion. This is a result of rivers eroding sediment to form meanders, which is simply a bend in the river. Keep in mind that whatever enters these streams is then transported throughout our ecosystem and eventually leads back to the ocean. It is important to note that whenever oil spills, agricultural runoff, or toxic chemicals enter these waterways, they can cause devastating results. They can completely change and contaminate these waterways, not only affecting aquatic ecosystems, but also can affect terrestrial ones as well. It is important to keep in mind how interconnected our waterways are and how humans, wildlife, and plants rely on clean water to survive. Thank you and have a wonderful day. Until next time. And remember to just go with the flow.
1, 2, 3. G.